Math. When you need help, you use Minute Math.
I'm Sean Gannon, and this is Minute Math, and today we're learning about similar figure word problems. A 6-foot-tall tent standing next to a cardboard box casts a 9-foot shadow. If the cardboard box casts a shadow that is 6 feet long, then how tall is it? So we have the tent and the box. Okay, so we got a tent here. It's like a triangle tent. All right, triangle tent. And they said that tent here is 6 feet tall. A 6-foot tent right there, and it casts a shadow that is 9 feet. Right. 9-foot shadow, right? We have a shadow there. Then there's a cardboard box nearby, okay? And that cardboard box casts a shadow that is 6 feet long. All right? What's the height there of that box? So we need to set up a proportion. All right, so we have the height, 6 feet, right? Height, 6 feet over h feet is equal to the length of the shadows as a proportion. These proportions, right, the measurements of them with shadow to height ratio should be the same proportion. So 9 feet to 6 feet, okay? So to solve that, we cross multiply. We're left with 6 times 6 equals 9 times h, and then divide both sides by 9 to get h by itself. So that h value we found to be 6 times 6 divided by 9 is 4 feet, right? So our height here is just 4 feet for that box. A telephone booth that is 8 feet tall casts a shadow that is 4 feet long. Find the height of the lawn ornament that casts a 2-foot shadow. So let's go draw a picture. We got a telephone booth right here, okay? Top there, little dome, little door, that's good enough. They tell us here that the height here is 8 feet. All right, we got 8-foot height, and its shadow length, right, the little shadow there, is 4 feet. So the shadow length is 4 foot long. Now, they say we have a little lawn ornament, make a little rectangle. I don't know what it looks like, what type it is. But they said this lawn ornament casts a 2-foot shadow. We need to find the height of this lawn ornament. So let's set up a proportion. The proportions of the height and shadows should, be the same proportion. So 8 feet over h, right, both the heights, equals the height of the first one, 4 foot over 2 feet. And now let's solve for that h. We cross multiply here. 8 times 2 equals 4 times h. We divide both sides by 4. This gives us h by itself, and 8 times 2 divided by 4 is 4 feet. And so my final answer here is just 4 feet for the height of the lawn ornament. A map has a scale of 3 centimeters to 18 kilometers. If Riverside and Smithville are 45 kilometers apart, then they are how far apart on the map? So what I want to do here, right? We take the scale. We know 3 centimeters represents or equals, right? Equals 18 kilometers. All right. So 18 kilometers in real life equals 3 centimeters on the map. Now they also say that 2 towns, right? They are 54 kilometers apart. So now we want to see how far apart they are on the map. Well, let's go set up a proportion, right? 3 centimeters to 18 kilometers. That ratio should be the same as x centimeters to 54 kilometers. And now let's solve for x. Well, we cross multiply here. We have 3 times 54 equals 18 times x. Then we divide both sides by 18. This gives us x by itself, and 3 times 54 divided by 18 is 9, and that's for the map. Our units are centimeters, and so our final answer here is just 9 centimeters on the map. Find the distance between Riverside and Milton if they are 12 centimeters apart on a map with a scale of 4 centimeters to 21 kilometers. So first thing here, we're given the scale. 4 centimeters on the map equals 21 kilometers in real life. All right. So they tell us that on the map, the two towns are 12 centimeters apart, and we have to figure out how far apart they are in real life, the real distance, okay? So with this information, we have to create a proportion. So 4 centimeters to 21 kilometers, right, that's scale, should equal our 12 centimeters to our x value in kilometers. And now we solve for x. Well, we cross multiply here. We have 4 times x equals 21 times 12. We then divide by 4 to both sides, gives us x by itself, and 21 times 12 divided by 4 is 63, and that's in kilometers. And so our distance between Riverside and Milton is 63 kilometers. A model house is 12 centimeters wide. If it was built with a scale of 3 centimeters to 4 meters, then how wide is the real house? So first thing I like to write down is my scale. 3 centimeters for the model is equal to 4 meters on the real house. Okay? All right, so 3 centimeters in the model is 4 meters in real life for this house. Now, the house, they told us here, was 12 centimeters wide. So we have 12 centimeters wide. Right, 12 centimeters here, and we have to find the real height, the real house's width, right? Let's call that x. So from there, now if you want a visual picture, right, you know, I'm Mr. Picasso here, got a little house. Really, our model, right, our model is going to have a width of 12 centimeters, and we have to find what the large house is. Obviously, that's not to scale because it's much bigger than that. I'm just kind of fitting it in here. What is that width? Okay? Well, with this, we can create a proportion. We know 3 centimeters, that ratio, all right, from the model to real, over 4 meters should equal 12 centimeters, the width of the model to the actual width of the real house, okay? And with that, let's go cross multiply and solve for x. 3 times x equals 4 times 12. We divide both sides by 3. X is now by itself, and 4 times 12 divided by 3 is 16, and this is in meters, and so that width of that house was 16 meters. Oak Grove and Salem are 87 miles from each other. How far apart would the cities be on a map that has a scale of 5 inches to 29 miles? So first thing is that scale. We know it's 5 inches on the map is equal to 29 miles in real life. Okay? So with that, they told us that our two towns are 87 miles from each other, and we want to find that distance on the map. So let's create a proportion. 5 inches over 29 miles is equal to x inches on the map over 87 miles. Now let's solve this proportion. Let's get x by itself. Cross multiply here. 5 times 87 is equal to 29 times x. Divide both sides by 29. We get x by itself here, and 5 times 87 divided by 29 is 15. And this is in inches, and so my final answer here is 15 inches on the map. A map has a scale of 2 inches to 6 miles. If Clayton and Centerville are 10 inches apart on the map, then how far apart are the real cities? So, first thing they give us a scale. 2 inches is equal to 6 miles. That's 2 inches on the map and 6 inches in real life. Okay? They told us in real life that two cities are 10 inches, or sorry, not real life, on the map are 10 inches apart. And we have to find how far apart are these real cities in real life. Well, with that information here that we created, let's write a proportion. 2 inches to 6 miles should equal 10 inches to x miles. Let's solve for x. Cross multiply here. 2 times x equals 6 times 10. Divide both sides by 2. X is by itself, and 6 times 10 divided by 2 is 30. That unit is in miles. Our unit is miles. And so our final answer, Clayton and Centerville, are 30 miles apart. A statue that is 12 feet tall casts a shadow that is 15 feet long. Find the length of the shadow that a 8-foot cardboard box casts. All right. So first thing, we're given this statue. All right. So the statue, I'll make it as a larger. This box, it's a rectangular statue, and it's 12 feet tall. All right. So they tell us that statue here is 12 feet, and it casts a shadow that is 15 feet. Okay, we got a little shadow 15 feet long. At that same time, we have a box, cardboard box, right? So their cardboard box here, they told us was 8 feet, right? 8 feet tall. And we have to find how far of a shadow does that box have. So we can set up a proportion. The height, 12 feet, over 8 feet, we have the heights here, is equal to 15 feet, the first shadow, make sure it matches up here, over the shadow of our box. Now with that information, let's solve for x. Cross multiply. 12 times x equals 8 times 15. Divide both sides by 12. X is by itself, and that is 8 times 15 divided by 12 is 10 feet. And so the box casts a shadow that's 10 feet long. A model house has a scale of 1 inch to 2 feet. If the real house is 26 feet wide, then how wide is the model house? So they give us this scale, right, of 1 inch equals, right, 1 inch to 2 feet. And that's 1 inch on the model. And our real house is 2 feet there, okay? If the real house has a width of 26 feet, right, this is how wide it is, right? 26 feet wide, then how wide is the model house, right? So we have our real house, a lot bigger here, and they say its width is 26 feet, and we have a little model house here. As you see here, my daughter in the background saying daddy and throwing stuff down the stairs, but that's okay. And we define the width of that model. We don't know what it is, all right? So we can create a proportion. 1 inch to 2 feet is equal to x inches over 26 feet, all right? Now we want to solve this proportion. Cross multiply. We have 1 times 26 equals 2 times x. Then we divide 2 to both sides. X is by itself, and 1 times 26 divided by 2 is 13, and that's in inches, right? And so our width here is just 13 inches for that house. A 6.5 foot tall car standing next to an adult elephant casts a 33.2 foot shadow. If the adult elephant casts a shadow that is 51.5 feet long, then how tall is it? Okay? So one thing that tells here is that we have a car, excuse me. We have this car, very tall car, okay? But let's say it's a truck, right? There's a little truck here. There we go. That's my crappiest looking truck. But they tell us that this truck here, right, the truck has a height of 6.5 feet, all right? And it casts a shadow here, that shadow length of, not to scale, 33.2 feet, okay? That's a weird looking 3, so 33.2 feet. Now, we got an elephant. Oh man, I'm gonna draw an elephant. I'm horrible at drawing. I don't know. They're kind of big, right? And they got a little trunk. And then it's a trunk, and then they're roly-polies. It's kind of like a weird looking duck thing. I don't know. They got a little tail, and they got big elephant legs. And this is the saddest looking elephant. Oh my goodness. And they got like big ears, right? And I don't know, that trunk, and then little tail, and it's like a duck elephant. Anyway, this is like the horrible drawing, but it's okay. That's good. I'm not here to show you how to draw and show you how to solve this word problem, right? So this little elephant casts a shadow that's 51.5 feet long. And feel free to write in the comment section how bad of a drawing my elephant is. Okay? We want to find the height of the elephant. This is so bad. Alright, at least the car kind of now doesn't seem so bad. Alright, I don't even know what that was. Was that a windshield or I don't know, doors and crap, maybe even worse. Alright, let's set up a proportion here. So, 6.5, that's 5 feet, I can't even write words now. 33.2 feet. So we have a height to shadow ratio for the car. Should be the same ratio as the height to shadow ratio for the elephant, 51.5 feet. Now let's solve for h. We cross multiply. 6.5 times 51.5 should equal 33.2 times h. We divide both sides by 33.2 to get h by itself. And our height here of the elephant, we take 6.5 times 51.5 divided by 33.2, we get a 10.1 feet. And so the height of our elephant here is, I don't think it's going to fit, but 10.1 feet. All right? After all that. If a 42.9 foot tall flagpole casts a 253.1 foot long shadow, then how long is the shadow that a 6.2 foot tall woman casts? All right? So let's go draw a little diagram here. We got a little flagpole. A little flagpole here. I should have done that, but a little flagpole. We got a flag on it. All right? There we go. Little flag. Now this flagpole, right? If the flagpole, they tell us, is 42.9 feet tall, all right? And it casts a shadow, and that shadow is 253.1 feet long, all right? And then we got this woman standing there. I'm not an artist, but there we go. We got this woman standing there. All right, and she is 6 feet tall, 6.2 feet tall, actually, 6.2 feet. How long will her shadow be? All right, so with that information, we want to create a proportion. The height, 42.9, over her height, which is 6.2 feet, should equal the relationship of the shadows, 253.1 feet over x. Her shadow length. Okay? So to solve, we cross multiply. 42.9 times x should equal 6.2 times 253.1. We divide both sides by 42.9, not 429, but 42.9. This gives us x by itself, and 6.2 times 253.1 divided by 42.9 is 36.6 feet. And that is the length of the shadow that the woman casts. Georgetown and Franklin are 9.7 inches apart on a map that has a scale of 1.1 inches to 15 miles. How far apart are the real cities? So we're given a scale. Let's start with that. 1.1 inches is equal to 15 miles. So it's 1.1 inches on our map. In real life, we got 15 miles, excuse me. Georgetown and Franklin, they said on the map, are 9.7 inches, and in real life, we want to find out how far apart they are. With this information, we can create a proportion. 1.1 inch to 15 miles should equal our 9.7 inches to our x miles, the distance that we want to find. To solve this, we have to cross multiply. 1.1 times x is equal to 15 times 9.7. Divide both sides by 1.1. We got x by itself, and 15 times 9.7 divided by 1.1 is 132.3 miles. And so that's the distance, our final answer, between Georgetown and Franklin.
Minute Math. When you need help, you use Minute Math. Minute Math. When you need help, you use Minute Math. MinuteMathTutor.com.